Hello everybody, I am your mentor Muhammad Tariq, and today we are continuing with the concrete technology, and I'll be picking up the slump test with the types of slump and the IS code. This PPT has already been uploaded before, and just before this I have uploaded the workability of cement concrete. And just for your concern, here is the block that I have created, and this is the link. You'll find it even inside the even below, and then you have this YouTube channel you can subscribe to, so you'll get it directly. This website has been created, though I'm not very good at creating a website, but I've tried somehow to create a website, and this is also active right now, so you can go through them. So we'll first continue with the IS code in very brief, and then finally we'll get down to the procedure of slump test, and we'll take out the slump, and I will give you also the details in this video of how much the slump should be for different construction work, for beams, slabs, mass concreting, etc., etc. So here right in front of you is the IS code 456, in which we take the slump in mm, and for ordinary RCC work, that is for beams and slabs, it should be 50 to 100 mm. Then we have the workability of concrete. Now, for the workability of concrete, which is of higher grade, that is M25. When we say M25, it means that it will acquire a strength of about, compressive strength of about 250 kg per centimeter square, or you can say 25 Newton per mm square. And for M30, it is 300 kg per centimeter square and 30 Newton per mm square. Since mostly we achieve a slump of about 63 mm to 59 mm, so it is important to reduce the slump. Slump means the settlement that has to be decreased. The slump has to be decreased, and for this we use biomass ash, and this biomass ash is added in the required grade, that is M25, M30, and the slump is brought up to 46 to 48 mm. So now we have some of the cement ratios as mentioned over here, that is 1 is to 5 is to 10, 1 is to 4 is to 8, 1 is to 3 is to 6, 1 is to 2 is to 4, and 1 is to 1 is to half is to 3. Here the concrete grade is given as M5, and next for 1 is to 4 is to 8 is 7.5, 136 is M10, and 1 is to 2 is to 4 is M15, and 1 is to 1.5 is to 3 is M20. Then we have the compressive strength in kg per centimeter square, that is in MKS system. So you can go through these things. Then we have in Newton per mm square. and here we have the compressive strength in FPS system. So this is how we'll go through these grades. Now after this, these are the normal grades that we use over here. Here I've specified the normal grades of concrete. Next we have these standard grade design. So in these standard grade design, 1:1:2, that is M25, has a compressive strength of 250 kg per centimeter square and 25 Newton per mm square, or you can also say megapascals. Then we have the compressive strength in FPS system. It is 625 psi. Psi is nothing else but pound per inch square. So I mentioned it on top right over here, which shows that what it means. Now any other design that we use has to be design mix. Like over here, all of these ones, they have to be design mix, and according to that we get the acquired strength, that is M30, M35, 40, and for that matter of fact 45, and this is the MKS, then Newton per mm or SI units, and FPS or FPS strength given over here. Then here we have the concrete grades that are of high grade concrete, and the strengths are given over here, and these are all done or designed in order to get the mix. So here you can see they are all designed, and this is the compressive strength acquired in SI units, and this is the strength that is acquired in your foot or FPS system. Here we will discuss the purpose of slump test. As I've discussed in the last video that we take out the workability. So this is for taking out the workability of concrete. And how we do it, we'll see in this video itself. And it's quite an easy test, and the apparatus can be carried to the site as well, and both the tests can be conducted at the site as well as in the laboratory. Number 3, it provides a convenient indication about the uniformity or the quality of concrete from batch to batch, or the cement that we have procured at our site, we can test it that how the quality of cement is. So it is very important to note these things whenever there is major and mass construction or concreting going on. And next are the factors that influence the slump test. It is the chemical factor, the finest particle size distribution, the moisture content of aggregate, the temperature, it varies with temperature, then the cementous material, then the size we have discussed in our workability test. So the size, that is the size of the particles that we are using. If coarse sand is thin or thick, it makes a difference. So does the stone grit makes a difference. Even the texture of the grade makes the difference. Then the combining of the grade, how we mix it up, how much mixing has been done properly. That's quite an important factor, and if you've not seen it, you can go back to the previous video of workability, and I've shown you the procedure of mixing, that is dry and as well as wet mixing. Then the cleanliness, the water that should be used should be clean. So now we'll come back to the figure of the slump cone and we'll discuss the types of slump. And maybe the video is becoming lengthy, so I could distribute it in two parts. So I'll see and decide.